All right, so the last video notes for this section is going to go over oxidation numbers. And oxidation number just means basically the charge of the element or the compound itself. So that's just a fancy word for that. Okay, so we're going to kind of do a little bit of a review. So when I'm looking for oxidation numbers, you're trying to find the total charge basically of these compounds by finding out what the individual charges are. And so that way we can find out what the total charge is. So if we go back, remember we said CaCl2 is my example. So first of all, I'm going to look right here. So let me get my pen work first. So I'm going to look right here is, do I see a charge right there? If it's blank, that means no. That means your total net charge is going to be equal to 0. Okay, so that means you had just enough positives to balance out just enough negatives. Because if we found out the charge of calcium off your periodic table is +2, and the charge of chlorine off your periodic table is a -1, but I have 2 of them, that means my total negative charge will be -2. So if you take +2 and -2 and put those together, that gives you a net charge of 0. So that is why you don't see a charge up here in this compound. So that is why I drew this arrow right here explaining that if you don't see anything, that means the net charge is 0, and that's what we're going to set it equal to. Now, when it comes to monatomic oxidations, these are probably the easiest. Okay, so again, if you do not see anything present right there, that means you cannot see a charge. It will be equal to 0. So if I asked you what would be the oxidation number of iodine or I2, you would just simply say I equals 0. Okay, now if you do see a charge, so like on this one I have a Cr with a +8, okay, so that one does have a charge. So if I asked you what is the oxidation number or charge of chromium in this case, your answer would simply be +8. Now, those are probably the easiest part of this note, so we're going to get into the little bit tougher part. So again, it's not too bad, but let's move into the polyatomics. Now, when you have a covalent bond, so remember covalent bond meant that they coexisted. That means they are both, so meaning multiple atoms from the right side of the staircase, which was your non-metals. And remember, in a covalent bond, they don't really give each other electrons. They just kind of overlap their electrons to kind of help each other out. Okay, so we basically need to find is what is the charge of each one that's present in that covalent bond. Okay, since they're both on the same side, we can't really just look at the groups and say what charge each one has. So if I look at something like this, like chlorate, ClO3, okay, oxygen is going to have a -2, and then chlorine would have a -1 if you were looking at the periodic table, which wouldn't make sense because negatives don't really attract negatives. And that's pretty much true, is they're not really, it's the covalent bond is one of your weaker bonds because they're just kind of sharing common electrons. It's not really like an ionic bond where you're taking one from another and it creates that strong bond. Okay, because since these are all negative, we have to find out that something's not the same as just simply looking at the charge at the top of a group. So we need to find out who's different. Now, so our example here, so I have everything kind of written out here. If you pull up my presentation, it goes step by step, but I'm going to talk about this step by step. Our example is BaSO4. So basically what we're doing is I'm asking you to find the charge or the oxidation number of each element in this BaSO4. Now your first step is to look and see, do we have a charge right here? And no, we do not. So that means we're going to set our whole thing equal to 0. So no matter what charges I have for each one, I know the total should come out to 0. Okay, so again, that is why I bolded that right there. Now, my next part is to spread the elements out, and I write how many I have from the formula. Okay, so spreading them out just gives you some room. So I have 1 barium, I have 1 sulfur, and I have 4 oxygens. Okay, so that's my first step, is just kind of spreading them out to give yourself some room. Now, number 3 is you want to set up the total line and our charge, our net charge. Okay, because what we're going to do is we're going to find the charge of each one. So the charge of each one will be right here. And then the total charge of each one will be right here. Okay, so and then we know that our total has to equal out to 0 right here. Okay, so that's your second step, is after you spread them out, draw your total line or your sum line, and then what it's going to be equal to, and it's equal to 0. Now, step 4 is always start with oxygen. oxygen will always be -2. So that means you can put -2 right here. Okay, so pretend this 8 doesn't exist right now, so I'm just going to cover that up. Okay, so I know that each oxygen has a charge of -2. And if I have 4 of them, that is why 4 times 2 equals -8. That's how I got that -8 right there. Okay, so I've got my first one done. So I know my charge for oxygen is going to be -2. Okay, so again, when we do oxidation numbers, I care about what is the charge of each one. I don't really care about the total. I just want to know what is the charge of each one that's present. Okay, so there's part of my answer right there. Now, if there is a metal present, which there is, barium is a metal, that means we can just look on the periodic table from that one. Okay, so we're going to give you barium, which is in group 2. Okay, so group 2A, so that is why it has a charge of +2. And pretend this +2 isn't right here right now on bottom. So since I have 1 barium and I have a charge of +2 for a barium, so 1 times +2 would give me +2. Okay, so far I've got 2 answers down. I know that oxygen has a charge of -2, and I know that barium has a charge of +2. Oops. Okay, so now ultimately what we're doing this for is to find the charge of that sulfur. So since sulfur is bonded with that oxygen, it's going to have a different charge than you would typically see on the periodic table. So that's the whole goal of us doing this, is to find the charge of that unique sulfur. Okay, so now let's move on to our next section. So now this is where we get to do a little bit of math, okay, a little bit of figuring it out. It's not too bad. So we're trying to find the charge of this sulfur right here. So we don't know what the charge of one sulfur is, but we can probably find out the total charge for all of the sulfurs. Okay, so the way I look at this is, let me clear out these marks real quick. Now I have it written down here, but I'm going to write it out to the side. If I have a +2, okay, I need to know 2 plus what? -8 equals 0. Okay, so my whole goal is to total out to 0. So how can I get from +2 to something else? -8 gives me 0. Okay, so well, hopefully you can kind of figure that out. Is 2 plus 6 minus 8 gives me 0, because 2 plus 6 gives me 8, and then 8 minus 8 gives me 0. So that means this right here is going to be a +6. Okay, so that means now what we can do is we can take that total which we just found, which is a +6, and then divide by however many sulfurs you have. Okay, so since I only have 1 sulfur, so +6 divided by 1, that means the charge of my sulfur is a +6. Okay, so that's where you kind of get to do a little bit of figuring out to see what's the missing piece. So my total answer, or my complete answer, would be barium would be a charge of +2, sulfur would be a charge of +6, and then oxygen would be a charge of -2. Okay, so now let's move on to another example. Okay, so this one is already kind of completed, but I'm going to show you step by step. Okay, so again, if you need to go back to the notes to look at each step, how you go, I'm going to try to explain it out as we go. Now, when you have something like this, aluminum perchlorate, okay, and you have parentheses, this is where you got to be careful. When you have a parentheses, you have to cross multiply whatever the number is on the outside. So you would take this 3 and multiply it by the 1 chlorine, and then take that 3 and multiply it by the 4 oxygens. So that means you have 1 aluminum, because 1 aluminum's off by itself. This 3 does not affect the aluminum because it's not in the parentheses. You only have 1 aluminum. And I have 3 chlorines, and then 3 times 4 gives me 12 oxygens. So when I spaced these out, I wrote aluminum has 1, chlorine has 3, and oxygen has 12. Okay, so let's kind of clear that up a little bit. Now, remember your first step was to start with oxygen. Each oxygen has a charge of -2. Okay, so oxygen is always -2, so you should always start there. Now, 12 times 2 is going to, 12 times a -2 is going to give me a -24. Okay, so part of my answer is done. Okay, oxygen is going to have a charge of -2. Now, remember our next step was to work on, I'm going to change colors for this. My next step was to work on the metal if I have one, and I do have one. It's right here. It's my aluminum. Okay, now aluminum you can just look up on the periodic table. It has a charge of +3, and since I have one of them, 1 times +3 gives me +3. So that means my total charge for aluminum is +3, and that means my charge for each aluminum would be +3, since there's only one. So there's the second part of my answer. Now, the whole goal of doing this is to figure out what chlorine is. Okay, so we're trying to figure out what is the charge of each chlorine. And you cannot just simply look up on the periodic table and see what chlorine is, because this is a covalent bond. This is not like the ionic nomenclatures you've been doing in the past homeworks. Okay, so now what we're going to do is we would basically need to pretend that these aren't there. Okay, so I would need to see 3 plus what, so my question mark would be right here. 3 plus what minus 24 gives me 0. So ultimately is what minus 24 gives me 0? Well, that would be 24. So 3 plus what gives me 24? So that makes this a 21. Let me actually make my eraser a little bit smaller. That would make this total a 21. Now, my total charge for chlorine is 21, but I want to know what is the charge for each chlorine. So since I have 3 chlorines, I would take my total charge, which was 21, and divide it by however many you have. Okay, so that is why each chlorine is going to have a charge of +7 right here. Okay, so that would be my answer right there. So chlorine is going to have a charge of +7. Oops, don't know how I did that. There we go. So now I can look, is aluminum has a charge of +3. There's my first answer. And then chlorine has a charge of +7. There's my second answer. And oxygen has a charge of -2. And that's my third and final answer. Okay, so now let's go to the next one, is when there is a charge. Okay, so it's the same steps as you did before. It's just now we have a different number. We're no longer setting it equal to 0. We're just setting it equal to -1 now. Okay, so nothing different. You just change out what you're equal to. Okay, so let's look. So I have NO3 with a -1. So my first step is I'm going to figure out how many I have. I have 1 nitrogen and I have 3 oxygens. And then my total is going to equal out to a -1. Okay, so again, if you don't see anything here, that's when it equals to 0. But if you do see something, that's when you're going to set it equal to that charge. Now, my next step, okay, is going to be, I'm going to write it out here. I know I have it written down in the next step, but I'm going to write it out here just in case you want to see it. I have N1, O3, my sum line, and then I know it's going to equal out to -1. Now, remember your first step is to start with oxygen because it's always a -2. Okay, so each oxygen is going to have a charge of -2, and I have 3 of them, so 3 times -2 gives me -6. Now, this normally would be the part where I go find the metal, if there was a metal, but since there is no metal, I don't have to worry about that. I can just move straight onto my nitrogen. Okay, so now I need to figure out is what -6 gives me -1. Okay, so hopefully you can kind of figure that out. Okay, I would know that ultimately a +5 -6, so a +5 -6 would give me a -1. So that would be my total charge for nitrogen. So what you're going to do is you're going to take your total charge, which would be a +5, and divide it by however many nitrogens you have, which would only be 1. So that means my nitrogen is going to have a charge of +5. So now I could fill that in right here. Okay, so that would be your complete answer, would be N equals +5 and oxygen equals -2. Okay, so that sums up for the notes on this one. So I'm going to do more examples on the homework, so hopefully that will help you out as well.